Okay, so we're going to talk about some telescope technology, and we all know about Hubble and what's currently deployed, but what's on the horizon? So NASA's going to take us through a series of videos to talk about our applications like the James Webb Telescope, TESS, and the Nancy Grace Roman Telescope.
TESS, the Transiting Exoplanet Survey Satellite, is NASA's newest planet hunter. The mission has operated for 2 years and has now mapped about 75% of the sky. This enormous area of coverage gives scientists unprecedented opportunities to search for new worlds beyond our solar system, as well as other cosmic phenomena. TESS completed its initial sky survey in July 2020. This giant mosaic is made from 26 sector images. Each sector is a 24 by 96 degree strip of sky monitored by TESS's 4 cameras for about a month. Here are some of the noteworthy discoveries from TESS's second year. TESS discovered a trio of planets around GJ 357, a red dwarf star just 31 light-years away. The system's farthest planet, with about 6 times Earth's mass, is especially intriguing. It orbits in the outer part of the star's habitable zone. If this planet has an atmosphere thick enough to keep its surface warm, liquid water could exist there. TESS found another planetary trio around the star L98-59. The innermost world is the littlest found by TESS and is 20% smaller than Earth. Later, scientists announced TESS had observed a star being torn apart by a black hole. Catching one of these tidal disruption events showcases the mission's ability to spot many kinds of short-lived phenomena, like stellar outbursts and supernovae, underscoring TESS's importance for studies beyond exoplanets. In early 2020, scientists announced TESS's first Earth-sized planet orbiting in its star's habitable zone. This world, called TOI 700d, is a little larger than Earth and probably rocky. Based on TESS and Spitzer data, researchers were even able to model potential weather systems. Analysis of the planet's atmosphere, if it has one, will have to await future space-based observatories like NASA's James Webb Space Telescope. Missions like TESS and later Webb help contribute to the field of astrobiology, the interdisciplinary research on the variables and conditions of distant worlds that could harbor life as we know it. TESS has found many systems very different from our own. TOI 1338 has a Neptune-sized planet orbiting a pair of stars. Kelt 9 has a fast-spinning star with hot poles and a cooler equator. Kelt 9b orbits over the poles, resulting in star-induced seasons that only last a few hours. Now that its primary mission is complete, TESS will return to the southern sky for another year-long survey. Many new planets, as well as more brief cataclysmic events, await astronomers as they scour the flood of TESS observations.
So this next section, we're going to talk about Nancy Grace and who she is. So Nancy Grace is known as the mother of Hubble. So she was born in 1925, and in 1959, she joined NASA. That's just about 6 months after NASA was established. You can imagine in the time, equal rights were not really what they are today, and obviously we still have a long way to go. But she was fighting an uphill battle to say the least. Now, lucky for her, she joined NASA. She did identify during her employment that she did feel like a peer and an equal, and we see that across the board with individuals like Katherine Johnson and other strong women in NASA's history. So, what she was able to do was that she was able to launch a series of satellites that demonstrated the value of space-based astrophysics. And at the time, that was just a pipe dream. You know, it was something that was an unproven concept. Just because We were trying to figure out what kind of images that we could actually collect from deep space, and we were having a problem with trying to get those images within the Earth's atmosphere. So then she took it to the next step. In the 1960s, she was a pivotal individual who convinced NASA and Congress that we really need to fund Hubble and go explore those deep spaces. And obviously, as we know today, Hubble is something that we all benefit from. So this next generation of Hubble, which we call the Nancy Grace Roman Telescope, is based off of her. It was named after her, at least.
The universe. For all we have learned about it, we have only just begun to reveal its secrets. What are dark matter and dark energy? How common are planetary arrangements like our own? And how many planets in our galaxy have the potential to harbor life? The Nancy Grace Roman Space Telescope will help answer these fundamental questions. Formerly known as WFIRST, the Roman Space Telescope is similar to Hubble, but with the benefit of 30 years of technological improvement. Each image from its wide-field instrument will have the depth and clarity of Hubble's best, but capture a sky area 100 times larger. The Roman Space Telescope will take the lead in exploring dark energy and dark matter. We only know they exist by their effects on observable matter, yet these two mysterious components make up 95% of the universe. The Roman Space Telescope's powerful 2.4-meter mirror and enormous field of view will also help us in the search for planets beyond our solar system, or exoplanets. It will watch for gravitational microlensing events, caused when a planet and its host star pass in front of a background star. Such events are rare, so catching them requires watching large swaths of the sky. To deepen its study of exoplanets, the Roman Space Telescope will house a beyond state-of-the-art coronagraph that will directly image and analyze Neptune-sized planets in orbits slightly larger than Earth's, a dramatic improvement over current capabilities. The Nancy Grace Roman Space Telescope will help us answer many of the biggest cosmic questions. Its wide-field view and coronagraph will complement missions like NASA's James Webb Space Telescope and Transiting Exoplanet Survey Satellite, TESS. The Roman Space Telescope will be an indispensable part of space science during the next decade and beyond.